Look at the moon. Now imagine that, between one heartbeat and the next, it is simply gone. No explosion. No fragments. No flash. Just an empty patch of sky where a world used to be. This cannot happen under known physics. But if we grant that impossible premise, the consequences reveal how deeply the moon is connected to Earth. Some changes would begin immediately. Others would take generations, or millions of years, to unfold. And contrary to the usual disaster stories, the oceans would not instantly swallow every city. So what really happens when the moon disappears tonight? For the first moments, almost nothing on Earth moves differently. The moon is about 384,400 kilometers away, so changes in its light and gravity cannot reach us instantly. They travel at the speed of light. For roughly 1.3 seconds, Earth continues to see and feel a moon that no longer exists. Then the moonlight ends. Away from artificial lights, a full moon night can be hundreds of times brighter than a moonless one. The familiar landscape collapses into darkness. But Earth does not stop rotating. It does not leave its orbit around the sun. The ground does not split open. The moon and Earth orbit a shared center of mass, yet the sun dominates Earth's journey through the solar system. Removing the moon changes Earth's motion, but it does not launch the planet into deep space. The first dramatic difference is not destruction. It is absence. There are no more lunar phases, no eclipses caused by the moon, and no silver path across the ocean. Human calendars, navigation traditions, and cultures built around the lunar cycle lose their physical reference in a single night. For wildlife, darkness is not merely visual. It is information. Many marine animals time spawning, feeding and migration with moonlight or the lunar cycle. Coral spawning can synchronize with lunar cues. Sea turtles and nocturnal predators use natural light patterns to orient themselves and decide when to move. Their responses would not all fail in the same way, and artificial light already complicates many of these behaviors. But an ancient, repeating environmental signal would suddenly be missing. By the next day, the oceans exposed the moon's largest everyday influence, tides. The moon does not pull only on the water directly beneath it. Its gravity varies across Earth, stretching the oceans into tidal bulges as the planet rotates beneath them. Without the moon, that lunar contribution disappears. But tides do not vanish. The sun also raises tides on Earth. Solar tides are weaker than lunar tides, so the familiar range between high and low water would generally shrink. The exact change would differ from coast to coast because shorelines, ocean depth, and basin shape amplify or suppress tidal motion. Some locations that now experience dramatic tides would become far calmer. Others would retain meaningful solar tides. This would not create one global wall of water. It would reorganize coastal rhythms. Intertidal habitats repeatedly move between air and sea. Salt marshes, mudflats, mangroves, and tidal pools depend on that cycle. Change the range and timing, and feeding grounds shift. Sediment moves differently. Nutrients mix differently. Harbors, tidal energy systems, and coastal ecosystems built around present-day conditions must adapt to a new pattern. The missing moon would also alter the length of Earth's day, but not overnight. Today, lunar tides create friction. As tidal bulges interact with the ocean floor and continents, Earth's rotation very gradually slows, while the moon slowly recedes from us. Remove the moon and most of that long-term braking disappears. The current 24-hour day remains essentially unchanged for human lifetimes, but its future evolution follows a different path. This distinction matters. Losing the moon would produce immediate darkness and weaker tides, but many of the largest planetary effects belong to deep time. The moon helps stabilize the orientation of Earth's spin axis. Our planet is tilted by about 23.4 degrees, which helps produce the seasons. Earth would still have seasons without the moon, the sun would still rise, and the planet would still rotate. But over very long intervals, the range and pattern of Earth's axial variations could become less stable. That does not mean Earth begins violently wobbling tomorrow. It means that across millions of years, the geometry controlling where sunlight falls could vary more widely and less predictably than it does now. Different simulations depend on interactions among the planets and on the starting conditions, so no honest explanation can give a single guaranteed future climate. But the principle is clear. Change the tilt, and you change how sunlight is distributed by latitude and season. A larger tilt can intensify seasonal contrasts. A smaller tilt can weaken them. Ice sheets, monsoons, deserts and ocean circulation respond over long periods. Life would not face one cinematic apocalypse. It would face a planet whose environmental boundary conditions slowly drift into unfamiliar territory. There is another absence that would reshape science itself. The moon preserves a record of impacts and solar system history that erosion and plate tectonics continually erase on Earth. Its surface has tested instruments, trained astronauts, and given humanity a nearby destination beyond our planet. Without it, future observers lose both an archive and a stepping stone. Our sky changes too. Total solar eclipses disappear. The extraordinary match between the apparent sizes of the sun and moon is gone forever. Night photography, astronomy, and the biological clock of human society adjust to a darker world. And yet, people survive the first night. Cities remain lit. Satellites continue orbiting Earth. The International Space Station does not fall. The oceans still move. The sun still raises tides. There is no instant end of civilization. That may be the most unsettling part of this thought experiment. The moon's importance is not best measured by one explosion. It is measured by countless quiet systems, water moving along a coast, animals reading the night, Earth's rotation losing energy, and a planetary axis remaining comparatively well behaved across immense spans of time. The next morning would arrive normally. The sun would rise over a world that looks almost unchanged. But every coast would be beginning a new rhythm. Every nocturnal ecosystem would be adapting to a missing signal. And far beyond any human lifetime, Earth would be entering a different climatic future without its ancient companion. The moon appears silent and distant because its influence is so consistent that we rarely notice it. Take it away, and the sky becomes emptier immediately. Earth becomes different slowly. And the longer we wait, the greater that difference becomes.